A very lovely hello to all class 9th champions, class 9th lovely kids. So first of all, I would like to welcome you everyone on your favorite channel, Deeksha Vedantu CBSE English, and this is your Sonu Sir. So my dear champion, if you remember, as I promised you guys in my last live sessions of this chapter, the world of numbers, in that live class we had solved a lot of questions, competency based questions, real life application based questions from this chapter. And in that live session I had promised you guys that I'll be uploading a one shot video of complete entire the world of number chapter. So this is that video. I'm fulfilling my words, I'm fulfilling my promise for you guys. So let's start this chapter, the world of numbers, the one shot. So in this single video, your entire real numbers, the world of numbers will be completed. Each and everything I am going to teach you guys here from this chapter. So let's start. So Ganit Manjari, of course, you have new textbook of maths, Ganit Manjari. Chapter number 3 is the world of numbers. So world of numbers, if we talk about, so there are few historical things are there. So basically, when you go to historical approach, I mean, you know, 500 and 1000 years ago, how the ancient people were counting. So they didn't know actually the counting 1 2 3. So to count the number of animals, when they used to go out with the animals to graze them and all, so they used to take pebbles and they used to keep the pebble in a pot, and according to help that pebble, I mean, they used to count the numbers. So 1 2 3 were unknown to them. They didn't know the counting, exact counting that we have in presently. Is from 0 to 1 2 3 we have everything, right? So from counting pebbles to the real number line. So we are going to discuss everything in this single video. So let's move ahead. So first thing here, let's talk about the target. So in this chapter, the journey of numbers. Let's begin with the journey of numbers. What does it mean by journey of numbers? I mean, how the numbers invented, how the numbers discovered, how you guys got the numbers that in present time we are having. I mean, we have a very powerful number 0 also. 0 is nothing, but that is everything. Without 0 you cannot write 10, without 0 you cannot write 1 crore, 10 million and all. So 0 is very powerful. 0 is nothing but everything, right? So now the journey of numbers, each new need in human history gave birth to a new kind of number, and every family contains the one before it. Yeah, if you go to history, so in every, I mean, at every particular period of time, the peoples were discovering the different kind of, I mean, the different categories of the numbers. So if I give you the short overview, basically this is called natural number, and it is represented by capital N. Natural number start from 1 and so on till infinity. W is for whole number. So after this 1 2 3, people introduced one more number, which is 0. So after inventing natural number, 0 was invented. So this introduced, the whole number came in existence, 0 1 2 3 and so on. After discovering whole number, the people were confused about negative. If you subtract, I mean, if the temperature is 4 degrees centigrade presently, and the temperature is, I mean, the temperature has become down by 10 degrees centigrade. So 4 degrees centigrade minus 10 degrees centigrade, the result will be minus 6 degrees centigrade. So people didn't know, the ancient people, about negative number. So after introducing the whole number, it came in existence, the integers. So in integers, we all know 0 comes up, positive numbers are there and negative numbers are there. So the combination of all negative, 0 and positive real numbers are called integers. Now rational comes up. The introduction, we'll be talking about rational also, and after rational, irrational is there. When we write root 2, root 5, root 7, they all are irrational number. I'll be teaching you, don't worry, what is the difference between rational and irrational. I will be teaching you everything in this chapter. And if we combine the rational or irrational, the combining rational and irrational, everything, all of these, whatever you study here, everything, this is called real numbers. This is called real numbers. So the numbers are categorized into two groups, champions. The first is real number and other one is complex. So in 9th class, we are not talking about complex. Complex is the situation whenever the numbers become negative under root. So we can write this as minus 7i. So that is called basically complex situation. You will be studying about this negative situation when the numbers are in negative but inside the root. This is called complex. You guys will be studying these things in the higher standard classes. So we are studying here everything, rational and irrational, and the combination of rational and irrational is called all real numbers. So if we combine natural number, whole number, integers, rational and irrational, this whole combination is basically real numbers. Please keep it in mind. What is real numbers? So the number whose existence is possible, the numbers which can be represented in some format, that is called real number. Simply, whether it is rational or irrational. But complex situation is some different thing. Okay, moving ahead. So together the rational and irrational numbers fill the numbers line completely to form the real numbers. I have already told you. So my dear, if anyone asks you, define real numbers, so you can reply him, the combination of all rational numbers, all irrational numbers called real numbers. Whose representation is possible. The numbers which can be represented on number line. Whether it is a rational number, whether it is irrational number, all the numbers can be represented on number line. Okay, have patience. I will be teaching you everything here. Now moving ahead. Now if we talk about the history, how the numbers were discovered. So let's talk about everyone little bit history. So the story of counting. How counting came in existence, how countings were introduced, that you guys study in your childhood in nursery 1, 2, 3, 4, 5, 6, 7 and 8. Okay, so counting was born from need herders by the Saraswati tracked their cattle with pebbles. I have already told you. So people used to keep the one pebble in a one pot. Okay, according to the present and absence of the animal, right? So cattle, animals. So this is all about, this is history. And using the pebble, they were able to find whether there are 2 animals present, 3 animals present, and 1 animal is still on the way. So with the help of pebble, they were able to count the number of animals present and how many animals are still absent. How many animals are still in forest or is on the way. This is all about. Second is the Lembombo bone, 35,000 years old, oh my god, and the Ishengo bone, 20,000 BCE are among the oldest record of the mathematics. Natural numbers is represented as capital N. We can write natural number starts from 1 till infinity and so on. The counting numbers, the smallest is 1. So the smallest natural number is of course 1, and there is no largest. We don't know. If I ask you which is the largest natural number, you can't reply. You don't know which will be the largest natural number because it is going and so on. No one knows which number will be the largest natural number because this is endlessly going in forward direction. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 till infinity. Apart from infinity, beyond infinity, no one knows. So my dear champion, there is no largest natural number. You can't write answer of largest natural number. There is no existence of largest natural number. No one knows. Okay, this is all about. Next is the Ishengo bone shows the column 11, 13, 17, 19. What do these numbers share? Basically in Ishengo bone, we are talking about prime numbers. This here, this was. Okay, so all the prime numbers, the next 3 prime numbers are 23, 29, 20, 31. So according to this methodology, this basically it was representing the prime numbers, and we all know the prime numbers which are having only 2 factors, 1 and itself. If I talk about 11, so 11 can be divided by 11 and 1 itself, right? So this is prime number. If I talk about 17, so 17 are only having factor 17 and 1. So 17 is also prime number. So this was the Ishengo. I hope this is clear to you. Now moving ahead. Now the second is section 3.2 is the invention of zero. It was a revolution in the world of mathematics. The invention of zero was like, a revolution in the field of mathematics. It was like a revolution in mathematics. Yes, my dear. If zero were not there, we were not able to write 1 lakh, 10,000. We would not have been able to go ahead. Bigger numbers, million and trillion and all. We would not be able to find out the distance between planets, distance between sun and earth, distance between two planets, because 0 is not there. So it was the revolutionary achievement in the field of mathematics. It was a revolutionary achievement. So ancient Indian thinkers turned shunyata. So it was called as shunyata in historical term. Shunyata, emptiness, I mean nothing is there. Emptiness means nothing is there. 0 represents, my dear, nothing. No value, nothing. No value. No value into a number, and it was represented as 0. Let's say, for example, there is a pot, there is a bowl, and in this bowl 5 oranges are there, and I have picked up all the oranges from the bowl. Now nothing is there. If nothing is there, it means how many oranges are there? 0 oranges are there. I hope this is clear to you. So if there nothing is there, so how to write the answer of this situation? So all the oranges were picked from the bowl, so no oranges is left in the bowl, and it implies that 0 oranges is there. No orange is there, so 0 is the answer. So this is all about Brahmagupta. It's 628 CE gave the first rule for using 0 and negative numbers. Yes, Brahmagupta was the great man, great mathematician who introduced 0 and a negative number, how to introduce negative numbers. So adding 0 turns the counting number into the whole number. So including 0, after including 0, this was the time when, this was the period when whole numbers were introduced, because Brahmagupta had introduced 0 for the first time. So the combination of all the natural numbers that usually starts from 1, including 0, this is called whole number. This is called whole number. Now the family of number is completed, because now we are able to write any number because we have 0. So it was the revolutionary achievement, right? Okay, key fact, when we add 0 to any number, the result is similar, and when we multiply 0 to any number, the result will be 0. But division, if we divide any number by 0, the situation is called undefined. We can't divide any number by 0. Division means getting the parts, but if you divide any number, if you divide any number 7 part 0, no result will be 0. Not defined, no result will be 0. Division means what, my dear? Let me tell you. If we divide 8 by 2, it means we are making 8 half. We are making 2 parts of 8. So the result will be 4. So 4 indicates is 4 is the half part of 8. But if we divide 7 by 0, it means we are getting 0 part of 7. That is not defined value. This is all about. So when we divide any number by 0, the result is undefined. Okay. Why is division by 0? For example, 5 divided 0 is not defined, and solution is given there. No number times 0 can equal 5. Listen, champion, listen. When we divided 8 by 2, the result is 4. Getting my point? Now, if we multiply these two numbers, 2 into 4, oh, we are getting same answer. So 2 times 4 is 8. But when we divide 5 by 0, come on, 5 by 0, and let's say here is some result. The result is not possible, let's assume. So my dear, the product of this and this should be 0, but the product of number itself and 0 is also 0. So this is not possible. This is not possible. So no number times 0 can equal 5. So there is no valid quotient. It is called undefined. This is all about. Moving ahead. Now it was the period when integers were introduced for the first time in the field of mathematics, in the family of mathematics. So integers below 0. My dear, we all know on number line this is 0, and here at the right side all the numbers are positive. And left side below 0, all the numbers found in negative form. Okay, now listen, integers means below 0. Let's talk about depths, losses and temperatures below 0 need numbers smaller than 0, the negative numbers. So first the question here comes is, why negative values were required? Why this is required? For example, if I ask you, I have 500 rupees. I have 500 rupees, but I have spent 700 rupees. Come on, 700 rupees. It means that I am under debt of 200 rupees. I might have taken 200 more rupees borrowed. I might have borrowed 200 rupees from any friend. So I am under debt of 200 rupees. So minus sign indicates I am in under debt. I had only 5 rupees, but I have spent 700 rupees. So I might have taken 2 more 100 rupees from any friend. So I am under debt. So negative is also very important, negative value. So my dear, debt, loses, temperature below. So these are the conditions when the result comes in negative form also, because debt means you are under, burden of borrow. You have taken some amount, you have borrowed some money from your friends, so you are under debt. You have borrowed some money. Loses, when you have lost something. Temperature, when the temperature is going down below zero. What does it mean by? You have 500 rupees, but you have spent 700. So 500 total your saving has spent, so the result is 0. Now you are going below zero. That is why result is negative. So when we go below zero, the result comes as negative. The result comes as negative. So below 0 need number smaller than 0, the negative integers. This was the period when integers was introduced. My dear, I'm teaching you everything here very stepwise. First, natural number was introduced. Second, whole numbers were introduced, and now integers are introducing here. So it was like period wise. People were achieving, different achievements period wise. First natural number, then whole number, then integer. Then we'll be talking about rational number also. Okay. So Brahmagupta called positive numbers as fortune. This word is mentioned in your Ganit Manjari textbook. So for positive values, Brahmagupta taken the word fortune. Fortune means when we feel privilege, when we are happy, when we are under profit. So this is called fortunate. And negative numbers were introduced as debts. Debts means you are under debt. You have borrowed some money, some amount of money from your friend, you are under debt. So debt is negative. No one loves debt. No one. Everyone expect some fortunate incident, something. Fortune comes in your life. Everyone expect you. We all are dreaming to feel fortunate and all. And debt means what? This is negative. So Brahmagupta selected 2 words: fortune for positive values and debt for the negative values. Okay. So let's do the question here. At noon, Ladakh is 4 degrees centigrade. So in afternoon, the temperature at Ladakh was 4 degrees centigrade. By midnight, the temperature drops 15 degrees. Come on, yaar. Listen, initially it was 4 degrees centigrade. And now temperature is dropped by 50 degrees centigrade. What is the temperature? What is the midnight temperature? Come on, 4 degree. Then it might have been 3 degree. Now 2 degree. Now 1 degree. Now what, my dear champion? 0 degree. Now again. So you are going beyond 0. So if you are moving beyond 0, below 0, the result will become negative. So we can find out. We can subtract directly 4 minus 15, and that will be minus 11 degrees centigrade. So the temperature at midnight will be minus 11 degrees centigrade. Why? Because the temperature is going dropping by 15 degrees centigrade. So 4 degree was the earlier temperature. And now it would have been 3 degree, 2 degree, 1 degree, 0 degree. Now decreasing by 15 degrees. So what would be the temperature at midnight? The final temperature will be minus 11 degrees centigrade. So this was the time when negative values were introduced. Moving to next. Okay, now Brahmagupta rules. Let's talk about Brahmagupta rules for sign. So this is very simple. Plus, when you multiply plus, the result will come plus. When you multiply minus, the result will come. It means that when the values are identical, signs are identical, plus, their multiplication will be plus. Whether the signs are positive or the signs are negative, the result will always remain positive. But when the signs are different, plus minus or minus plus, the result will come negative. Right, my dear champion? So this is all about, very important, we all know. So minus 15 into 5 will be what? Minus 12 into 5. Now multiply sign first. So this is negative and this is positive. So negative positive, negative positive is negative. So negative sign will come. Now multiply the number. So 12 5 just 60. This is the answer. And similarly minus 8 minus 7, minus minus will become plus. So we don't require to show the sign. If there is nothing, it means plus sign is there. And 8 7 is 56. This is the answer. Moving ahead. Now let's talk about very interesting rational numbers. Very interesting and very powerful rational numbers. So basically rational numbers are the numbers which can be represented in the form of P by Q. A rational number has the form P by Q where Q can't be equal to 0. When you write any number in the form of P by Q, the numbers that can be written as P by Q, numerator by denominator, but the condition is denominator should not be equal to 0. Denominator can't be equal to 0, because if denominator would become 0, this result will become indefined, because a number cannot be divided by 0. We know the rule. We have already studied earlier in previous slides. So Q should not be equal to 0. This is the format of rational number. Are you getting my point? Are you getting my point? So all the terminating decimal and non-terminating recurring decimal all will give you a rational number. So let's talk about slowly. Every integer is a rational number. Yes, of course, because n can be written as n by. For example, if I ask you 7 is a rational number or not? Yes, because 7 can also be written as 7 by 1. And this is the P by Q format. If I ask you minus 5 is a rational number or not? Yes, minus 5. Whether the integer is negative, we have already said here integer. And if we are saying integer, it means we are introducing positive values, negative values and 0 also. So 0 is also a rational number. Yes, this is interesting. So my dear champion, if I ask you 0 is a rational number or not, you might get confused. Oh my God, sir, 0 is a rational number? How is it possible? The condition for rational number is the number should be written in the form of P by Q. How we can represent 0 in the form of P by Q? Yes, we can represent 0 as well. Listen, my dear, if I write here 2 by 0, 0 by 2, what does it mean by 0 by 2? Come on, yaar, 0 by 2. Oh my God, 0 by 2 is equivalent to 0. And this is the format of P by Q. Q is not equal to 0 because the denominator here is 2. And this is the condition for rational number. So 0 is also rational number, because 0 can be written as 0 divided by any number, 0 divided by any number. So my dear, or we can write 0 by 11, 0 by 9, we can write anything. All these values will give you 0. So 0 is also rational number, and that is why I have given you the statement, every integer is a rational number. Because it can be written as, since it can be written as n equals to n by 1. Okay, now moving ahead, fractions and all terminating or repeating decimals are rational too. This is very important point that you need to be noticed here. Terminating and repeating decimal. All the terminating and repeating decimals are rational. Okay, you might get confused. Let me give you an example. So my dear, listen here. I'm giving you example for the third point. My dear, if I have written here 4 by 3, now divide. If we divide here 3 1 ja 3, this will be 0. 4 minus 3, 1.0. 3 3 ja 9, 1 0. 3 3 ja 9, 1 0. 3, oh my God. This division is continuously going on, endlessly. It will be never stopped. If you divide point carry 0 0 0, it will be moving on. So after decimal, 3 is continuously repeating. You can see there. 3 said we are dividing this 4 by 3. So 3 1 ja 3. 1 is getting here. After putting decimal, we got 0. So 3 3 ja 9. 1 0. Oh my God. So this result, this quotient can be written as 3.1.3 bar. Why? Because it is repeating continuously. So this is called a repeating decimal. The division is not terminating. So this is non-repeating, but non-terminating but repeating decimal, because same digit is repeating again and again. I hope you are getting my point. Right? Now, listen. simple. If I ask you again here, 3 by 4, this is 3 by 4. What will be the result? 3 by 4. Check it once. If we divide 3 by 4, what will be the result? Check it once. Come on. So 0.47 ja 30, wow, 0.75, and it will be completely divided. Yes, the division will be cancelled. It is terminating. This is non-terminating. This is terminating. So, my dear champion, whether the situation is non-terminating, repeating, or terminating decimal, both situations are a rational number. So, this is rational number and this is also rational number. So, if the decimal is non-terminating but repeating is also called recurring. So, non-terminating, repeating, or terminating decimal. For example, let me give you an example. I am writing here 1.2, and one more decimal expansion I have is 1.7575, 0.75757, and so on. My dear, this situation is called terminating because division is completed at 0.2, and this is here in this quotient 75 is continuously repeating in regular pattern. So this situation is called non-terminating because it is not terminating, division is still going on. So it is called non-terminating but repeating. Non-terminating, repeating. So my dear champion, if any one of these two situation is there, so my dear, both can be written in the form of rational. So whether the decimal is a terminating type or whether the decimal expansion is non-terminating repeating type, both will give you rational format. Both are rational number. But simultaneously, let me give you the clarity on this. My dear, if you if you write the value of root 5, so when you calculate the value of root number, if the number is under root, except perfect square, I'm not talking about root 4, root 9, root 16 and root 49. I'm talking about such type of number. Right, so root 5 will give you 2.23, and if you calculate the value, I'm not forgetting that value, so you can directly write 2.23, and if you move ahead, 2.23, 5, 3, 6, 7, 1. This type of result will come. Nothing is repeating systematically. At every division, something new is coming, something new is coming, something new is coming. So if this kind of situation is there, my dear, this value might be incorrect because I'm giving you the example. So we generally memorize a decimal place of 2, so I know 2.23 is there, but you can recheck. But what I want to tell you guys, 2.23 and after 3, the numbers are continuously repeating, but in unsystematic order. It is not repeating with proper rhythm, with proper order like this, 757575. Here, every number is shuffling, unsystematic format is there, and this situation is called irrational number because such format can't be represented in the form of P by Q. This root 5, root 2, root 7, root 11. So that's why all the root functions, if the number is under root, will give you irrational number. All are irrational number except perfect square. I'm not talking about perfect square. Okay, so my dear, this is why can't be written in the form of what? P by Q. So which decimal expansion can only be written in the form of P by Q? If the decimal is terminating or if the decimal is non-terminating repeating. But non-terminating, non-repeating, this is non-terminating and non-repeating because number is not after decimal. The numbers are repeating but in very unsystematic order. Numbers are shuffling a lot. So this is what. So this is called terminating, this is called non-terminating repeating, and this is called non-terminating non-repeating. So all the non-terminating non-repeating decimals will give you irrational number. So that's why. Okay, moving ahead. So question is, why do we insist that Q is not equal to 0? I have already told you the definition, because if Q is a divisor and division by 0 is undefined, we all know, so Q can't be equal to 0. So in rational number, this is the format of rational number, when the numbers can be written in the form of P by Q, where Q should not be equal to 0. I hope this is clear to all. Okay, moving ahead. Okay, when are two rational equal? This is a very simple question. When the rational numbers will become equal to each other? When you cross multiply, if two rational numbers are equal there, when you cross multiply diagonally the numbers, and if the right hand result and left hand result are equal, you can say that both the rational numbers are equal to each other. Let me give you an example here. For example, if I ask you, let me change the color of pen. This is 2 by 3 and this is 4 by 6. Now if I ask you, check whether both the rational numbers are equal or not. So my dear, do one thing. Do the cross multiplication. Tan -ta. 6 2 ja 12. Tan -ta. 4 3 ja. Oh wow. The results are equal. That it implies both the rational numbers are equal. Magic. For example, one more example. Let's take here. 3 by 5 and this is 6 by 10. Come on. Now check whether both the rational numbers are equal or not. So do the cross multiplication. 3 10 ja 30. This way. And 6 5 the 30. Wow. We are getting same result. It implies that both the rational numbers are equal. Let's take one more example. Okay, let's take one more example. 1 by 4 and this is 3 by 9. Now check whether the rational numbers are equal or not. So 9 1 ja 9, cross multiplication, and 4 3 ja 12. Oh my god, numbers are not equal to each other. So both the rational numbers are not equal to each other. They are unequal to each other. I hope you have understood how to check whether the rational numbers are equal or not. So if P by Q is equal to R by S, now you have to check whether this rational number is equal to this or not. So do one thing. If and only if P and S cross multiplication is equal to QR cross multiplication, multiplying or dividing the numerator and denominator by the same non-zero integers give an equivalent fraction. So this is all about standard form reduced to lowest term, keeping the denominator positive. So one more method is there. Second method, my dear champion, second method is, that is 2 by 3. I am taking first example and this is 4 by 6. Now if I ask you which fraction is smaller, I mean which fraction is having greater values, greater number. So this fraction is having greater number. Here is 4, here is 6. So try to make this fraction simplest. So make it simplest. 2 2 ja 4, 3 2 ja 6. Now check. Now right hand fraction has become equal to left hand fraction. So this is also indicating both the fractions are equal to each other. So you have two methods. You can check by cross multiplication. If the results of RHS and LHS are equal, then it implies that both the fractions will be equal to each other. Or you can follow, either you can follow by making the bigger fraction, I mean the fraction having bigger values, bigger numbers, you can make that fraction in simplest form. Now you can check whether the fractions are equal or not. Moving ahead. Okay, operating on rationals. So let's do little bit operation to the irrational numbers. What kind of operation? I mean addition of irrational number, subtraction of rational number, multiplication of rational number and all. Okay, so add, subtract, make the denominators equal using the LCM. Add very easy. Let me give you. And multiplication, we know how to multiply. The numerator will be multiplied with numerator and denominator will be multiplied with denominator. And divide, multiply by the reciprocal. Okay, rational, obey, closure, commutative, associative and distributive law. So there are few laws, my dear. Commutative law is when you add A plus B, that is equal to also B plus A. This is also in multiplication. When you multiply A cross B, that will give you result of B cross A. So this is called what? Commutative property. So this is valid in addition. In subtraction, commutative will not be valid, because when you subtract 7 minus 5, the result will be 2. When you subtract 5 minus 7, the result will be minus 2. So both are not equal to each other. So let's move ahead. Do the question. Compute 2 by 5 plus 3 by 10. Let's add this. So my dear champion, let me give you the short method of addition. First of all, look at the denominator numbers. So in both the fractions, in first fraction denominator is 5, in second fraction the denominator is 10. So now check both the denominators whether both the numbers are from same table or not. So 5 and 10 both are from same table. 5 2 ja 10. So you have to select the greater number. If the denominators belongs to same table, now my dear, you have to select the 10, I mean bigger value. What you need to do? First check whether the denominators belong to same table or not. And if they belongs to same table, you have to select the bigger number. Okay, 10 is there. Now read the table for this number, the denominator of the first fraction. At what position 10 will come in table of 5? So 5 2 ja 10. Now 2 will be multiplied that upper value, so 2 2 ja 4 will become. Now read the table of 10 for this number. So 10 1 ja 10. So 1 will be multiplied in that number, so 3 1 ja 3. So can we let me show you, let me give you here the elaborative form. 2 will be multiplied with 2 and 3 into 1, and the LCM is here. LCM is 10, right? So what will be the result? 2 2 ja 4 and 3 1 ja 3. So this is 7 by 10 is the answer. This is the answer. 7 by 10 is the answer. I hope this is clear to you all. Okay, moving ahead. Now, absolute value of a rational number. What is called absolute value of a rational number? My dear, this is very interesting topic. Okay, let's talk about absolute value of rational number. My dear, absolute value is basically represented under mode. This is called mode. When we draw two vertical lines and something is inside the vertical lines, so that format is called absolute value or modulus value. So this is, if we write any rational number under this modulus, that will give you the result as it is, whether the value is negative or positive. So x indicates that x will always be greater than or equal to 0. X can't be negative, because absolute value, when we write negative rational number under mode, under two vertical line, that will be automatically become positive. So this is called absolute. Look my dear, under mode x is negative x when x is less than 0. Its distance from 0 never negative. The distance, see, the representation is negative, but if you calculate the distance always remain positive. So distance can't be negative. Now let's, for example, champion, look at here, under modulus 3 by 4. This is called modulus, mode. So mode 3 by 4 will give you 3 by 4, or if mode minus 3 by 4 is there, it will also give you this. So this is called magnitude. Basically here we are talking about magnitude of rational number. Magnitude of rational number. Rational number. Or we can also say a strength of rational number. I'm not talking about identity of rational number. We are talking about strength of rational number. Strength of rational number. For example, listen. This is 0 on number line. This is 1, 2, 3, and here is minus 1, minus 2, minus 3. And now at this position I have kept a football, and anyone from you is standing here at 0. You are standing here at 0. Now I have given you one more information. This 1 unit is equal from 0 to 1. This one gapping is equal to 1 unit. Now my dear champion, football is kept at minus 3. Now if I ask you what is the distance of football from you when you are standing at 0, so now I am asking you the distance. So what you will be replying here? What you will be replying to me here? The distance will be what? 3 unit. Come on. You will not be telling me minus 3 unit. Minus 3 is the identity of this position. But this entire distance will always remain negative, positive. So such situation is called absolute value. Absolute value of the rational number means strength, magnitude. So if you write here positive of absolute, so that will give you this 3 by 4 is the absolute value. So the mode 3 by 4 will become 3 by 4, or minus 3 by 4 mode is also will give you the result positive. A number and its opposite share the same absolute value. So mode 0 is 0. The absolute value is 0 only for the number 0 itself. A minus b, if the numbers two integers are subtracting. So a minus b gives the distance between a and b on the number line, champion. It will give you the distance between a and b on the number line. So let's do one question. Evaluate this modulus of minus 7 by 5. What will be the result, champion? If minus 7 by 5 is under mode, so this will be equivalent to 7 by 5. This is the absolute value. Now second is minus 2 plus mode of 3. So minus, this was the first. Now second is this. So minus 2 will become 2 absolute value, and 3 is 3. So the answer will be 5. So positive, and here is also positive. Moving ahead. Okay, now, oh, very interesting now, decimal expansion, champions. So let's talk about decimal expansion. Decimals tell the difference. So a rational numbers, decimals either terminate, I have already told you. Look, what is the difference between this representation and 0.333 and dot. What do you understand by this? 0.75 and 0.33 dot. It indicates this is basically terminating because division has ended up. But here division is still going on. Here division is still going on. 3. It is not ending. 3. So this is non-terminating. But one thing is very special here. After decimal, same thing is repeating. Continuously. 3 in regular pattern. So this is called non-terminating repeating. Non-terminating. In some book, you might be finding this recurring word, recurring. So non-terminating repeating you can say, or non-terminating recurring. Okay, so this is all about. Second is an irrational numbers decimal expansion is non-terminating, non-repeating. This is very big difference here. Rational number, non-terminating repeating can be written in the form of rational, but this is non-terminating and non-repeating. Let me give you an example. If you write the value of pi, so this is 3.14, but here if you go to the number, the numbers come as different kind of number, and it is not repeating in systematically. Different kind of numbers are there, 3.14, 3.17, unsystematically. So this repetition is unsystematic. So this is called non-repeating. And here repeating is systematic, 3. So this is called repeating decimal. I hope this is clear to you all. Okay. So my dear, I'm just writing here the value of pi randomly because I have memorized 3.14. You can verify the value after 4 what comes up. You can verify the values are coming, unsystematic repetition. The exact values might be here, little changes, but this is the format here. Okay, now any repeating decimal can be turned back into the form of So there are two possibilities. If the decimal expansion is terminating, or if the decimal expansion is non-terminating but repeating. Come on, yaar. Non-terminating, repeating. Both the conditions can be expressed in the form of P by Q. Both the condition can be expressed in the form of P by Q. Hence, whether the decimal expansion is terminating or the decimal expansion is non-terminating repeating, it is a rational number. But non-terminating, non-repeating decimal is not give you this non-terminating, non-repeating. This one. Non-terminating, non-repeating. This is basically irrational number because it cannot be expressed in the form of P by Q. Please keep it in mind. So there are only two possibilities, terminating and non-terminating. Let's take one example. Can you see the question? Express the repeating decimal 0.777777777 in the form of P by Q. Fraction means what? Fraction means P by Q. Right? So this is what? Non-terminating but repeating. So this is a special case. So we can of course form in the we can change the format of this 0.7777 and so on in the form of P by Q. Let's do. So here whatever is given there, always let equal to x, 0.77 dot. Now my dear champion, after decimal the same only 7 is repeating. 7 only 7. After decimal only one digit is repeating, so always multiply by 10x. If only one decimal is repeating, so multiply 10x both the sides. If after decimal 2 digits in combined form, let's say 72, so we have to multiply by 100 because we want to shift this decimal to this side after 1 7, right? So it will become 7.7 and it of course it is going on 77777. So this is basically your second condition and this is your first condition. Now subtract equation first from 2. So 10x minus x will become 9x, and 7.7 minus 0.7 will be only 7. So x is equal to 7 by 9. Wow, we have expressed x was 0.777. Now x is equal to 7 by 9. So we have expressed this format in the terms of 7 by 9. This is P by Q form. I hope this is clear to you, everyone. Clear, everyone? Clear, everyone? Should I move ahead to the next question? Okay, moving ahead. Okay, now recurring decimals and fraction. My dear champion, a rational decimal either terminates or recurs with the repeating block marked by a bar. So my dear, if 0.72, 72, 72 and so on, it indicates after decimal 72 is continuously repeating. So we can also write this whole entire format in short 0.72 bar, and this is the first line. So if bar is there, it indicates that is a rational number. For example, I'm writing here 2.777 and so on. So it can also be written as 2.7 bar. So if bar is there, it is clear that this is a rational number. It can be written as the form of P by Q. So that is the first line. A rational number decimal expansion either terminates or recurs with the repeating block marked by a bar is a rational number. For example, 1 by 3, 0.333, 1 by 7, 0.142. Oh my God. Can you see here? 142,857. Look at here. 142,857. Again, 142. Oh my God. How many digits are repeating here? 5 digits are repeating. Yes. So whether 1 digit is repeating, 2 digits is repeating, 3 digits are repeating, 4 digits are repeating, 5 digits are repeating, doesn't matter. You have to check. You have to check at least 6th place, till the 6th place, whether the numbers entire family is repeating or not repeating. So here 142,857 is also repeating. So my dear, we can write it as, here the block is 142,8, so we can write this whole format. It can be written as 0.3 bar, and this entire format can be written as 0.142,857 bar, because this entire family is repeating and both are rational numbers because bar is there. Clear? Okay, now to convert, let x equal to the decimal, multiply the power of 10. I have already given you, we have solved one question in the previous slide. A neat surprise 0.99 exactly equal to 9. Express the recurring decimal. Okay, let's solve this question, champions. So the question is express the recurring decimal as a fraction. As a fraction means P by Q. So let's do this question. So what we need to do? The given number, we have to take given number is equal to x. So x is equal to, is it visible to you all? No, this is not visible. Green color is not visible, so let's use yellow color. No, red color. So let's x is equal to 0.3636 bar. Now my dear, how many digits are repeating after decimal? 2 digits are repeating. But if 2 digits are repeating, complete multiply by 100 on both sides. Why? Because after decimal 2 digits are there and we have to shift this decimal this side, and we want to shift decimal from left side to right. So for this we have to multiply, and if you want to shift this decimal from right to left, you have to divide by 100. This is the method, my dear. To shift the decimal from left to right, we generally multiply, and to shift the decimal from left to right, right to left, we generally divide. By whom? By 1, 0 with 1. So here after decimal 2 digits are there, so we have to multiply here by 100. So multiplying by 100, so this will become 100x, and this will become 36 point. How many 36 are there? Infinite number of 36 repeating. So we can take one more, 36. Now this is your first and this is your second, right? Now subtract equation first from second. So this will become 99x. 100x minus x will be 99, and 36.6 minus 0.36. So this 36 will be cancelled. So we have only 36. So here x is equal to 36 by 99. Can we please cancel this? So this is 4 9 ja 36 and 11 9 ja 99. So we have x is equal to 4 by 11 is the answer. We have converted this whole format in the terms of fraction. So this is equal to 4 by. Now if you divide 4 by 11, if you do the long division, divide, let's verify. So this is 0.0 and this is 11 3 ja 33. Now 7 will come. This is 0. This is 0 3 and we have already taken decimal, so this will go 7. Now 11 6 ja 11 7 7 ja no 11 6 ja 66. Now we can take 4 here. Now here 0. So 11 oh my god, again same thing is repeating. So this is 0.36. Can you see here 36? This will say 3636. So answer is correct. We have verified the answer is absolutely correct. I hope this is clear to everyone. Moving ahead. Okay, rational on the number line. Wow. Now this time is to do something rocking, champion, something rocking. So my dear champion, now we are going to, till now what we did here, we have covered about all the numbers, decimal expansion, what kind of decimal expansions are there, about rational and irrational, about natural number, whole number and all. Now we are going to represent the rational numbers on number line. How to represent the rational numbers on number line? Let's start. Okay, so every rational number marks exactly 1 point on the number line. This is very important. Let me show you a short example. For example, this is number line, the middle is 0 and this is 1 2 3. Here is -1 -2 -3. Now my dear champion, if I ask you where will be 1 by 2? 1 by 2 is a rational number, but 1 by 2 can also be written as 0.5. Yes, 0.5 is a rational number, and 1 by 2 represents that, the half of 1, the middle of 1. So my dear, this is 1 here, this is 0 here, and half of this, because this is 1 by 2, so 0.5 will be lying somewhere here. 0.5 will be here. This will be the 0.5, which is also equal to 1 by 2. Now how to find it? So this was the logical. How to draw the, for example, if I ask you how to draw 7 by 4 on number line, how to draw 1 by 3 on number line. So these are the questions. So let's understand the concept, how you guys can comfortably draw, comfortably show the rational number on number line. I hope this is clear to you all. Okay. Let's do slowly. Entire questions has removed. What happened? Okay, no problem. Okay, moving ahead. So every rational number marks exactly 1 point on the number line. I have already given you an example. Now to plot P by Q, divide the unit gap between two integers into Q equal parts. Don't worry, negative rational sit to the left. We all know, because all the numbers left side to the 0 are negative. That's why negative rational number will also go to the left side, and mirroring the positive. So mirroring means what? Whatever is the left side, exactly same values will be at the right side, but the signs are different. Or we can also say whatever is the value at the right side, every value, same value will be at the left hand side, but there is the difference of only sign. Only sign different is there. We cannot take such a way. I mean, you are taking here 3 6 and you are taking 1 2 -1 -2. No, this is not possible. These values are the mirror image of this, and these values are the mirror image of this. Both are mirror image of each other. That only difference is of sign. So you cannot take different values both the sides. Please keep it in mind. Okay, the third point is negative rational set. Oh, we have already discussed. Now look at the question. First question, mark -5 by 4, 2 by 3 and 3 by 2 on the number line. So by taking the decimal also, you can draw the number line. If -5 by is equal to 1.25, 2 by 3 is equal to 0.67, 3 by 2 can also be written as 1.5, -5 by 5, and we have to arrange. So 3 by 2 is greater than, 2 by 3 is greater than minus 5 by 4. Now the main question is how to draw the rational number or number line. So we'll be discussing it later on, just wait a little while. Now first talk about density of rational numbers. So density means what, my dear? Density implies that. So moving ahead, density of the rational number. Okay, so thank you so much everyone, my dear class 9 champions. So this video is basically one short video of your real number, the world of real number, but this is part 1. In next video, I will be uploading part 2 of the one shot. So these two videos, see my dear champion, what happening here? This chapter is little long, lengthy. Lot of concepts are there. Few important topics, new things are introduced. And this chapter is also present in class 10th. But for this chapter is very, you guys are studying this chapter for the first time. So I cannot, managing everything in the single video will be little challenging for you to study. So I decided to categorize this one shot video into 2 parts, part 1 and part 2. So this is the part 1, and in the next video, very soon the next part 2 will be uploaded on the channel. Very soon it will be uploaded, don't worry, and please make sure to watch this video from starting to the end, my dear. And in the next part I will be discussing density of real numbers and number beyond fractions, how to represent, how to prove root 2. We have already studied root numbers. Under root numbers are always irrational, right champions? Root except perfect square, root 2, root 3, root 5, root 7, all are irrational. But how to prove mathematically? So there is very powerful method that is called contradiction method, and this question is very important. It will be definitely appearing in your board exam, in your exam at your school. You are in 9th standard, so of course in your final exam. So prove that root 5 is irrational number. Few more topic, the real number line, key formulas of glance, practice questions are there, champion. So yeah, so part 2 is going to be only of half an hour, don't worry. And my dear champion, this is my humble request to you all, please go and watch this video from beginning, from starting, champion. Thank you so much for watching. Thank you so much for having me and watching this video. Thank you so much, and don't forget to subscribe and don't forget to share this video with your friends. Bye bye everyone.